Okay.
Joo. No niin, yes.
So it might be good for you and for me that I'm losing my voice, so I won't say anything else stupid. But before I lose my voice, a couple of things. First of all, again, as a token of appreciation, we have taken it a step up in web dev and sausages, and we now have, as you can see, T-shirts. Yeah. You don't know how excited we were yesterday to get these T-shirts. It was like Christmas. So we also have T-shirts for Juha and Onni. If come and get your T-shirts, guys. I don't know if you're excited, but we are. You asked for small, right? Yeah. There you go. You're welcome. Yep. Okay. Okay, and then before we begin the last part of tonight, the WebAssembly challenge part, let me say quickly what the heck the WebAssembly challenge is. So, when, was it a couple of months ago, Leo? I don't know when we started coming up with the, what would be the theme, what are we going to do for the next meetup? I think I said, like, what if we had some kind of, like, let's do some coding? And then, like, people would come and show what they coded, like have a theme or something. And Leo said, yeah, that sounds cool, very positive. And he said, but it's got to be WebAssembly. What? WebAssembly? I'm not even sure I know what WebAssembly is. And but I thought, okay, he knows. And it's probably a good idea. So yeah, let's have a WebAssembly contest. And we actually then immediately sent out invitations to a number of companies. I won't say all the names of the companies because not all of them succeeded. But right after we sent out these invitations, we got really, really depressed because we had realized what we had done. We'd asked people to code in C for a technology that's just like barely come into the browser and is almost impossible to get to work. And like, who has time to do that? And we were immediately sure nobody is going to take the challenge and it's going to be a huge humiliation. And somehow we're going to have to pretend we never made the challenge. But we didn't have enough faith because there are so many smart hackers in Finland. 2 guys actually did it. And they deserve a lot of respect because it really is not easy right now to make something in WebAssembly. So those 2 guys are here. And they're going to tell you a little bit about what they did. They're kind of proof of concept. Actually, I think it went even a little beyond a proof of concept. So first, from my firm, we have Erkki's going to tell you a little bit, about in 15 minutes or so, what he did. And then Jaakko, who's from Futurist, is going to come, and he's going to tell you a little bit about what he did. And then we'll finish up by having a little bit of a discussion with all of us about WebAssembly. What is it going to mean in the future, and what did they think about it now after this experience? Okay, so now I'll turn it over to you to tell about what you did.
Okay, so hi everyone. I'm Teemu Erkkola, and I'm from Gofore. And these 2, Leo and Rick, they kind of ambushed me with this. So I've been doing some research into WebAssembly before, but I haven't really done anything real with it before this. So the first thing I started looking into is how does one do anything with WebAssembly? There are many languages now that say they support it, so you can code in C or C++, which is the official support, or you can code in Rust, you can code in NIM. I even heard there's some kind of TypeScript support, probably through Asm.js. So I started compiling all these ways to produce WebAssembly, and what I found was there was magic everywhere. So what I mean by magic is I didn't know how half of things was happening. I tried compiling some program, and then I looked at the results, and that didn't make much sense. Yeah, it worked, sure, but it used a lot of components that are not actually in the WebAssembly spec. So in addition, the files were pretty much always quite large, and I thought this can't be what WebAssembly can do. there must be more. So in addition, there was name munging. So all the exported symbols, the names everywhere were something else, and you just kind of had to roll with it. And there's non-standard ways of instantiating the WebAssembly modules and so on. There's all kinds of stuff that just happens that isn't in the WebAssembly spec. So there was this wonderful one gist that showed another way of making WebAssembly, and I actually found out that it can make clean WebAssembly from C. I'm going to show you just here. So, okay. So, a simple WebAssembly looks like that in the bottom. I'll just scroll a bit there. So, yep, it's in the middle. So you can see there that this is a simple example of what the text version of WebAssembly looks like. It's basically a kind of Lispy way of showing an abstract syntax tree, and this is just a function that adds two things together. So what I mean by magic is I'll just show you what the mscripting compiler does with the same thing. So there. Okay, can you tell me what that thing does? And there's actually, I found out that there's actually a kind of linear overhead. The bigger programs you start to compile using mscripting, the bigger the files are going to get, and it's not just at the same amount bigger than your source code was. So if you look at that and you just look at the same in C, well, that's not very good, is it? I like this one so much more. Okay, so this way of compiling these nicer versions, it's based on LLVM and CLang, the compiler. So LLVM has an experimental way to build it now that can actually produce this legible WebAssembly, but it needs to be compiled first. So what I did, it was use the gist I mentioned. I'll just... Okay, the gist is there. That nice, using WebAssembly in LLVM. Yeah. And based on it, I made a makefile that actually compiles and installs a local version of LLVM, CLang, WABT, that's WebAssembly binary tools, and all the other things you need to produce WebAssembly from C. This clean WebAssembly. And then, of course, since you have to use like 4 different tools to do all this, I also made this other makefile that makes it actually quite easy to produce all these intermediate formats that are needed. There's LLVM bytecode, bitcode actually, and then there's the S expression format, and there's the WAT. I like that extension. That stands for WebAssembly text, and then there's the actual WASM WebAssembly bytecode format. So to show, let's just pick import export, and I just say this one, and it tells me what's inside there. Okay, so now I actually had a way of producing WebAssembly that I can read. There's no more magic. I could write this myself. It's easy, yeah. So now I can make something a bit more complex. Let's pick animation first, since it's such a nice visual example. Okay, demo effect. What is happening? I'm sorry. Yes, I'm serving a lot of something. Okay. Mm-hmm. Oh, it's probably the cache. Yeah, I should probably expunge the cache. Ah. No. Since the beginning of time. Forget everything. I just want to see my... Yeah, I'll check. Oh, why is it profiling? Stop profiling immediately. I don't want you to profile. Yeah, there it is. Okay, now there's something. Oh, yeah. This is just a small thing I did to test that it actually does what I want it to do. That's just something like 100 particles bouncing around. And it's using the HTML Canvas API to draw this. I've just mapped the Canvas API to be usable from the C side. And then I just use it to draw particles like this. It's really quite nice. And the performance measurement was actually there because I checked, and with a 5-second measuring interval, it's actually using about 10 milliseconds of CPU time, so it's quite efficient too. So, if I show you what that looks like. Actually, I'll first show you this one. Yeah, so I have a canvas here. I just pick a 2D context and define a couple of wrapper functions, which I then pass on to the WebAssembly engine. It sets fill color, set fill color, fill rect, get canvas width and height. And then I have, using the request animation frame, a timing for this, and that's it. That's everything here. The fetch and instantiate actually does the loading of the WebAssembly. This is the standard way of doing it, and none of the examples in, say, Mscription use this. I don't know why. It's probably for compatibility or something. But if I then check out the main.c, there's a little bouncy algorithm there, and there's an on animation frame, and that's it. That's my C code. All of it 59 lines. Yeah, that's a simple example. So now that I had something bouncing around, I thought that maybe I could map a little more complicated API. So I tried WebGL. Okay. Is it profiling again? Okay, I think this one, yeah. Stop profiling there. Okay. Why are you profiling? I told you not to stop. Oh, yeah. There's a moving triangle. Yeah, so the actual point of this one isn't the moving triangle, though it's so smooth. It's really smooth. But it's actually to show how you can map a more complex web API that depends on stuff like JavaScript objects into C, into WebAssembly. Because WebAssembly currently doesn't have any way. It has only ways of passing integers and floating point numbers, and that's it. That's all you're going to get. So you got to make do with those. Strings? Nope. You got pointers to memory and maybe some ways of interpreting that. But, okay, now I had a WebGL. That's good. So to cap this off, I'm going to show you what I did when I found out that I can use WebGL. I can show this in detail later, but you can also actually look at these from my GitHub. These are all runnable there. They actually run on your phone if your Chrome is too recent enough. Yeah. But the latest Chrome browsers run these with full 60 frames per second with no sweat. Okay, so of course I made a Pong. I always make a Pong. I try lots of different languages, and the one thing I almost always do is do a Pong. I got a Pong in Elm. I got a Pong in Scheme. I got a Pong in everything. But yep. I don't think there's a graphic library for brainfuck, so no, unfortunately no. Anyway, now I gotta check if we have sound in here. That's still the triangle. Yeah, this is the simple version of Pong. Okay, so I'm gonna check. Yes, I am serving Pong. How about this? But actually, you see the 0 there. That's actually the score display. So it's doing something there. That seems right. Yeah. Okay. And now I don't hear sound, so I'm gonna just do this real quick. Yep, it's using the built-in. So, okay. Where? This? No, it's not muted. How about television? Oh, you're right, of course. That's weird, but I guess I can just... I wonder if I can get it just from here. No? Is this muted?
Output devices HDMI port unplugged. Can you output devices?
Output devices?
And then change the ports.
No, actually it's not synced. Okay, well.
You should probably try recompiling your kernel.
Yeah, sure, of course. Yeah. But I have my phone. I actually just ran this example, so I can put the sounds through here. Okay, so these are nice sounds in square wave, of course. And it's actually nicely playable. It has, you can see it has these nice particle effects when the ball hits the paddles. It has this blended trail and everything. Okay, it's so nice. So, what this is actually doing... Okay, you can stop now. I needed to map quite a bit of the WebGL API to get this to work, but it's a static workload. It needs to be just done once it's done, you can just do OpenGL using WebGL like you would in normal C. So I'll just quickly show you what that looks like, and then it's time for questions. So first I'll show you the index file. There's quite a bit of stuff, as you can see. I need to map all of these into separate wrapper functions. There's some cases, I'll just skip here. You can see I need separate storage lists, storage arrays for the JavaScript objects that are generated, so I can just use indices to use them and all. And then there's the actual exported functions right there, and then it's just the regular stepping and fetch and instantiate. On the C side, we have all these externs that tell there is some function somewhere you can use, and the compiler takes care of everything else. Then I needed a couple of constants from the 3D context object of the WebGL context. So then there's a couple of shaders, simple shaders, just textured stuff with a per object opacity. Then there's vertices. Oh, there's textures. These are RGBA in hex code. Tail vertices, tail texture, paddle textures. These are all in here. These were nice to type out. Okay, then there's beep, boop, and bloop, the sound effects. You can calculate how long they are from getting the sample rate from your browser and then dividing it by that. A couple of structs and a particle system and balls and textures and all these nice things. Oh, there's the entire audio generation code. Right there. Yeah, rendering sprites, clamping, colliding sprites, and everything else. There's the key code, rendering a particle system, and so on. Yeah. Anyway, that's 476 lines. And if we check, that's still only 13 kilobytes of WebAssembly. The WebAssembly file. Do you mean the text format or the text format? Okay. You don't want to see the bytecode? Okay. Okay, so here you see first all the exported stuff, extern stuff. So these are the functions that come from somewhere. You can read what the parameters are, what the results are, and so on. Then there's a memory being initialized, some constants that are needed. These are the textures you can see. Okay, let's go through the textures. Okay, here we go. There's, for example, we're calling a GLTeX image 2D. We use a couple of constants there. And then we get a couple of local values that are initialized in the parameters. And there's some shifting and some multiplying. And there's the next call. So if you check out the calls, you can see what it's doing. And there's defining a function with parameters and so on. Of course, this won't be as readable as the C code, but you can actually, if you start from the beginning of a function, you can go down and follow both your codes at the same time and see what it's doing. It's actually quite straightforward once you get the hang of it. I needed to debug a few things, mostly related to memory management, because WebAssembly just gives you a block of memory and says, have fun with that. There's no malloc, there's no M3. I actually coded my own once. You want to see? Oh. Okay, there's a malloc. That's the entire malloc. And there's free and there's size. Okay, this can be used to implement a full-on dynamic memory management. It's really stupid. It doesn't fragment the blocks you've reserved. It just reuses them for anything you need after that. But it works-ish, and it starts allocating at say 1024. It's nice pulling pointers just from a hat. I own all the memory. Doesn't matter. But yeah, one thing you won't see in any of these main files is a single include statement. Not a one. Because I don't have anything. I only have C. Sometimes even, say, if I'm assigning a struct to another struct, the WebAssembly compiler actually generates a memcpy call, but I don't have memcpy. I can, of course, implement it myself, and then I have it, but it kind of assumes there's a memcpy, but there isn't. Okay, so this mapping from C to WebAssembly, it has all these kinds of small pitfalls, but it can be done, and it's quite straightforward once you get the hang of it. And then there's the mapping of web APIs to WebAssembly, so you can call them from there. So doing this back and forth mapping is what my demo is about. And the Pong is probably the pinnacle of this achievement. So, any questions before I bow out?
It's okay to leave the questions to the panel discussion.
Oh, that's good. That's good.
Let's leave the questions there.
Yes. So, okay. Thank you then. I'll see you at the panel.
Check this out. Wait, you gotta check this out here. We have special T-shirts for you. I survived the WebAssembly challenge.
Woo!
Wait, is that the right size for you?
M?
There you go. M.
Yeah. Thank you.
You're welcome. Jaakko. Where's Jaakko? Yeah. Some of you might be scratching your heads. What was that? It's okay. We're going to talk about the significance at the end. It was pretty cool.
Okay, can you hear me now? Great. No. So, how do I follow up after this one? I don't. But I did. Okay, hi everyone, my name is Jaakko Husso and I'm from Futurize, and I took this challenge a couple of months ago. I had no idea what WebAssembly is, basically, and I just was working on this project that basically captures your webcam and records GIFs out of it, removing the green screen background the setup has. And this was the project I was working on. I had a working prototype using WebGL with the library, and it was actually working quite well. And then this challenge was published, and I was kind of interested to try doing this green screen removal with the WebAssembly. And unlike Teemu, I decided to roll with the magic. And I was using an mscript compiler with this WebAssembly init library. So basically all I did was I just installed an npm component and run it. So whereas Teemu was writing this excellent, I mean they are really good to make files, and I think the work here he has done should be published somewhere else as well. I just installed this magic generator, and I'm gonna go through what this approach does, but the files that this generates are nowhere close to being as elegant as the files Teemu created. Also, before I the reason I picked this approach was that I was initially trying to build it myself with similar methods that Teemu was doing, but I couldn't get them working. I was just met with these friendly error messages like expected magic word found, and yeah, those were fun to debug, and I just gave up. So. Yeah, so that's what happened. But anyways, here's actually the WebGL version I had before this. You can this actually also supports your webcam. I just imported this green screen video here because I don't have a green screen here, but you can record it and it will be created as a GIF and uploaded to Amazon. That's basically what this does. And yeah, great moves. And what I've created is the same with WebAssembly. And the result is not as nice because my code for removing the grid was really lazy and bad, but it still works and it's still a smooth 60 FPS. How this library works is that it creates you a config file that basically defines you need to have an mscript installed somewhere on your computer. You need to point to it. You just define your input file, the output file, and the functions you want to export from the C++. And here's my fancy, not fancy C++, which just calls this remove green, and it works by converting the RGB values for each pixel into HSV and removing the 3D portion of the color space that contains the green colors. And this is loaded into the code with magic, basically. When I run the compile that this handly tool gives me, it creates the WebAssembly file and a bootstrapper JS file. And basically here what I'm doing is that I'm fetching the WebAssembly code, and then I'm basically here exporting the functions that I want. And what I'm doing here is that I'm actually passing the canvas pixel data to my WebAssembly by allocating some memory for it and just passing the memory to this remove green function that I have. And this is a way that the mscript and this toolset allows you. Like you don't need to code the malloc yours by yourself. You just get it for free. I don't know how efficient it is. Most likely it's not, but it works. And here in my driving logic, I just get the where am I? I just get the WebAssembly here, and I can for each frame I can just remove the green from the pixels and draw the canvas. And what I should have done, I should have done the canvas mapping just like Teemu did. I think that was a really clever idea, and I didn't even think about it. I just kept passing the memory to the C++ code and back and forth, and that really slowed down my performance quite heavily, but it worked. I don't know if I have anything to add after his presentation, but anyways, I got my thing working, and it's awesome. Yeah, should we just move on to the panel discussion? I don't know if I have anything else. I was planning to, yeah.
Jaakko, you definitely earned your I Survived WebAssembly t-shirt. Custom designed by Leo. There you go. Good job. Just occurred to me, Teemu, I called Teemu, I think, Erkki about 5 times. That's because I have a beloved friend named Erkki who reminds me of Teemu. But don't take offense, Teemu, wherever you are. So let's talk a little bit before we finish off the evening. So, Teemu, if you would come and sit down. Jaakko.
By the way, my code supports the includes. Yeah.
Ooh.
The magic.
So we'll take questions for the audience. In the case that you don't ask good questions, I have a few backup questions. But maybe before we take questions, could one of you just, for those of us who don't know very much about WebAssembly, just say something quickly about the promise of WebAssembly? Like, why is it an exciting thing at all? Why are we doing this challenge? Why is it interesting?
Okay. For me, the biggest promise of WebAssembly is actually breaking the JavaScript hegemony. So other languages can compete in a level playing field. And, well, of course, there's performance benefits, but I think those are secondary to the actual cultural benefits that WebAssembly can bring to the web development.
Yeah, I feel the same. The reason I'm interested in WebAssembly is that in future it could bring us multiple different ways of doing web development, not just JavaScript, because it's been supported natively on the browsers. Only a couple of browsers at the moment, but still.
Okay, let's take some questions. I have this thing now that he stuck in my head. Yes, back there.
Yeah, it's kind of a comment and a question at the same time, I guess. To me, it seems WebAssembly is the way to do web development for people who are familiar with C but didn't bother to learn JavaScript, as you already kind of said. And then they kind of complain about the limited environment when they are actually familiar with C, but then the same way the environment is limited if you're working with Arduino or other C-based stuff that is physical limitations or whatever. But the question which you already kind of referenced as well is the performance benefits. So you've done Bong in everything.
Yeah.
So I guess you've done Pong in JavaScript.
Sure.
So can you compare those two things for us?
I haven't checked the performance of the JavaScript Pong, but I think I can answer this in two parts. So first, the performance of the WebAssembly Pong was that it was using just a few milliseconds of any CPU time for several in measurement of several seconds, and most of that is actually the canvas rendering stuff and not actually the WebAssembly. But there are also benchmarks that show that WebAssembly can be about twice the performance of JavaScript in typical cases. But I have to add that there's also another kind of overhead that one can miss there. So there's also other transpilable languages that transpile to JavaScript, and they don't always produce an optimal result. So of course you can always handcraft better JavaScript if you know exactly what you're doing. Typically, yeah. But so there's that small overhead also. But I don't consider the performance to be the be-all end-all of WebAssembly promise. And I see more collaboration than fighting in the future.
Jaakko, did you have anything to add?
Not really, no.
Okay.
Yeah, to comment on the collaboration and not on the fighting, actually that's a very good point. And as you already shown that you've used a lot of things along with WebAssembly, WebGL, and did you even have TypeScript?
There was the web audio API I
Yeah.
was using, of course, and then the key handling was, of course, from window key events and so on. There's some wrapping involved. And also the scoreboards for the Pong, those were just HTML. They're just, it's a callback from the WebAssembly to the JavaScript to set the score.
So in a sense, you could kind of read between the lines that it will expand the possibilities that we have to develop for the web.
Yes, and there will probably be WebAssembly parts in JavaScript modules so that you don't even know you're using WebAssembly. It's just there to optimize some small parts of the JavaScript libraries. So that's the kind of collaboration I'm hoping will emerge.
I'm curious to hear because all the examples I've seen are like these really cool games, right? Like Unity games that you can play in the browser. Have you played any of those, Jaakko?
I've tried the Unity demos that run on the WebAssembly, and
Yeah.
I got them working on my browser, but the games are not really that interesting. So
Yeah.
I've just
But-
tried them.
The reason I bring that up is because like that's cool, but most of us don't make games, unfortunately. So most of us are making like big, boring enterprise apps. What do you think the first sort of interesting WebAssembly applications will be in sort of more everyday web development shops like the ones that we work in? Do you have any idea of what sort of modules we'll be using, what sort of applications there could be?
I'm thinking that the modules that will be using WebAssembly first will be those like more hard on CPU stuff like the canvas rendering or audio stuff like we have seen here. Even though those are most used on the games, I still think that many like visualizations could use WebAssembly in future.
Yeah, definitely every kind of real-time applications like games or sound or moving images or something like that. Those are kind of the obvious ways of using WebAssembly, but it can also be used. I think there's some kind of project for implementing a virtual DOM using WebAssembly so that it runs with a predictable memory footprint. It loads faster since WebAssembly can be pretty much run almost as it's passed. So it will result in faster loading web pages with smaller file sizes, smaller memory footprints, and some performance benefits.
Okay. Any other audience questions? Comments? Yes.
How about the security about the sandboxes? Are the memories allocated for the page only? Are the pages only allowed to use the memory allocated to them, or did you find like any hacks that you could possibly do with the web assembly for now?
I haven't seen any hacks, but maybe you have.
Okay, so the WebAssembly memory model is actually quite well defined, and it can't access memory outside itself because the memory is all virtually mapped into a specific memory region, so there shouldn't be any way of accessing outside memory. Also, the runtime for the WebAssembly will probably just error out if you try to overreach a memory block. So I don't see any ways of interacting with external memory, but of course the internal memory of the WebAssembly program is vulnerable to all kinds of stuff like typical C programs can be, but that's inside the module, so you just have to clean up after yourself and you're golden.
I'm feeling pretty sad that the Flash is dying. So I was thinking that maybe Adobe could do this revenge and come back through WebAssembly. What do you think? Would it be possible to introduce this Flash player through WebAssembly and then revive all these nice vector animations that we have had so many years?
Well, if you saw the mapping I had there, well, you pretty much already have their way of running almost native code that uses OpenGL directly. So it's just a matter of a library for providing the vector primitives and such, and maybe a way of loading a file that describes the scene and such. So, well, at least it's possible using the Canvas and the WebGL interface, but I kind of would like to see a way of accessing these APIs from WebAssembly directly, so that it can be JIT compiled to go straight to the WebAssembly API inside the browser without the wrappers. So yeah, there's probably going to be some way of making scenes like we have seen in Flash, but these will be done in open web technologies and not some proprietary blob.
What do you guys think? Can you drop drones from the sky or set a computer on fire with WebAssembly?
What do you think?
No, but at least it's quite easy to get the browser frozen with WebAssembly at the moment. So that's an easy way to annoy your user. But that's possible for JavaScript as well. So nothing new.
Are you guys going to continue? Or are you going to do something else now with WebAssembly? What do you think?
I think I'm just leaving this branch and let it die because the existing stuff I had before this challenge was way easier to do and the performance was better. So I don't know. Maybe in the future when the toolset is more easy to use. At the moment it was a bit of a pain to just get the thing compile and work. Yeah. So and the browser support is terrible at the moment.
Yeah, I'll probably do something. Nothing flashy, but I'm still interested in how the LLVM and CLang compiler does the memory mapping stuff and using static allocation and all that stuff. But also I'm following Rust's, the language, not the game, advancements in producing WebAssembly. Currently it uses mscripts and with some kind of default settings and produces almost 120 kilobytes of stuff, whatever you compile, so that's not very good. But I'll follow the scene and maybe make some small stuff.
Okay, are there any final questions before we hit the social? Yes, in the back.
Yeah, I think you should try porting Qt first because that would be really useful. And I actually hope that I expect someone will port that in, say, 2 years or something because I think it should be feasible. In any case, my question is that can those WebAssembly, like you can load multiple WebAssembly blocks in one page, but can't they interact with each other in any way except through the JavaScript?
Yeah, no, currently they can't. I think there's a proposal for a future some kind of way for them to share memory pages or something like that. But currently no. And regarding Qt, yeah, I would like to see especially QML and Qt Quick working in a browser. But I think there should first be, say, standard libc or something compiled before we move on to anything like Qt.
It will come.
How should I put this? You kind of referred that there are challenges, of course, with the language itself that is not supported by browsers, or like not referred, but just said, and it's clear. But what do you think, on your experience, how usable is it now if you don't count the support for the language, but the way it is at the moment, as you kind of already use a lot of different things to make a very simple thing, and referring from that, what can you make with the assembly itself? Is it ready to deploy? Can you actually make anything with it?
No, don't use it in production yet. Mostly because of the tooling, it's quite unpredictable at this moment. So wait until there's official support in compilers, and after that, maybe if you have something once compiled, something like a big game or something, that can be done. But if you want to do releases all the time and do small changes and in general make maintainable software, then I think you should wait for the compiler support to merge.
But I must mention that the make files you did actually work on my machine as well, so they were kind of good.
Guys, respect. That was like very cool that you did this. And Leo and I are also appreciative because you saved us face. It would have been really embarrassing. I think Leo would have had to re-show his number adding code that he
Yeah,
made
add
with
two
WebAssembly.
numbers again.
Yes. Okay, I think this wraps it up. Of course, we still have some time just to hang out and drink beer. One last thing before you leave, except thanks for coming. If you would like to give Leo and I a little bit of feedback, here's a link. This is basically just 2 questions like, feedback about tonight and then ideas for the future for web dev and sausages, cool things that we could try, topics we could take, places we could do this. So it's not mandatory, but we'd appreciate anybody who could give us some quick feedback on your phone or take the link and give us some feedback tomorrow. Yes. I'm now really losing my voice. But thank you. And Leo, do you have anything to say in parting?
Thank you.
Yeah,
Nothing
enjoy.
else. Yeah.
Drink the rest of the beer on Vincent, on Vincent's bill. Yeah, okay. Have a good night.
Yeah, have a good night. Thanks.